I want to go and solve another problem which is a little, different than this, to show sometimes it is really easy to get confused. Right now I'm saying, if the question is shortest path, BFS is really a good solution. But sometimes we have shortest path problem, but the definition is a little different. And DFS, or recursive solution, is a little more, efficient. I don't know if everyone is with me. I want to go to the next element, next problem. But it is not BFS. We want to go over DFS in grid. But it is really misleading. The problem definition is really misleading to use the BFS. But if you go BFS, it will be really, tough and difficult. You can implement, but always we should, search for optimal and easy solutions, not only optimal. So let's say we have, again, a grid. The first time I saw this problem, I did my best to use the BFS, but I solved it, but it was really difficult to solve it with, using the BFS. But when you go to the DFS, it is really easy to solve this problem. Let's go to this problem. Again, we have a grid, and in my example, we have 4 rows and 6 columns. And again, I want to write 0, 1, the indices. But in this problem, we don't have any 0 and 1s. We have some integers. We have some integers, and let's say 0, 2, 3, 2, 4, 5, 6, 1, 1, 20, 7, 1, 0, 3, 3, 2, 8, 1, 1, 4, 3, 2, 0. The question is, what is the shortest weighted path from 0 to 0? Actually, from, let's say the source is 0 and 0, and the destination is 3 and 5. It doesn't matter, we can assume, we have a source node, a source cell, and, the destination cell. Destination can be anything, okay? But the path, what is the length of the path? Is the weighted, it is weighted path. For example, if I go, let's say, this path, what will the answer will be 2 plus 1 plus 1 plus 4 plus 3 plus 2. This will be the cost of this path. It will be 4 plus 4 is 8, 10, 13. 13 will be the answer, right? But let's say, again, movements, you should, again, finalize the movements. Which movements are, valid? Right now, let's assume, we have only left, right, up, and down. Or let's say, make it easier, right and down. We have only 2 movements, right and down. Okay, we have only 2 movements. It is really important. You should discuss about the movements when you have a question. You in the interview, you have to finalize all of the assumptions. So right and down. So let's say, we have this, and we can have, some other, paths also. What is the question? What is the minimum path? Let me run my code here. Actually, I have the source code, I implemented all of these guys in my computer, and I will actually share this, the source codes of the problems I'm solving, in the meetups. Okay. As you can see here, again, we see the shortest path term. And we think about, maybe the BFS is triggered in your mind. So it is shortest path. I have to use the BFS. What was the power of the BFS? The power of BFS was when we go hop by hop, and because we go level by level, definitely whenever we reach the destination, we have the minimum length. But right now, the value of each cell is different. They are not in the same, they don't have any same value. If I go one by one, it doesn't guarantee that, whenever I see the destination, I have the shortest path. Because the path, the cell's value is different with each other, right? So when we have this kind of problems, that, level by level doesn't help, it is really easier to switch to DFS approach or recursive approach. The recursive, we use, for example, let's say here we go, let's say I'm, in the 0. I have two neighbors, right? This and this. I will, in the DFS problems, you should be able to see the problem in from, in top level. You shouldn't dive in the details of recursive calls. I want to find the minimum shortest path from 0 to the end, right? So how many options I have whenever when I'm in the node 0 and 0, or any specific node? Let's say I'm here. I have only 3 is my option, and 4, right? So let's say I'm in a specific cell. I have 2 options: down and left, down cell and left cell. Okay, let's say I'm calling a recursive function, recursive call for down and for the left, also a recursive call. What does it mean? It means that I'm calling same function. Let's say, I have a function, I want to write a func. We have a source and destination, right? We have source and destination. And this will return shortest path in number, right? It will return the shortest path then, okay? It will return shortest path then for me, right, to me. So we will check, whenever, I'm in a specific cell, right? Like, let's say, here in the cell 2 and 2, which is, the value 3. The whole, possible options to me is, the right cell and the left cell. Yeah, actually the right cell and down cell, right? Bottom cells, actually it is right cell, right, and bottom, okay? So I can call same function here, same function, but the source is different. Source is, actually source that, let's say, I want to write, sources bottom cell, right? And the destination is same. So let's say I'm calling this, I'm assuming, don't dive into, the recursives. I'm assuming this function will give me the shortest path if I go from this cell. I have 2 options in any cell. I have 2 options. I'm saying, okay, call, one recursive calls, right? Recursive call, and it will give me shortest path, let's say L1, the L1. And again, I will call, another function for sources, the right cell and destination. And again, I'm assuming it gives me, L2. I don't want, you shouldn't just check how it is done. If you go dive in, the recursive calls, you will miss the interview, definitely. So assume if at any point, we have 2 options in this problem. If we had, more movements, we could have, 4, 5, 6, doesn't matter. okay? Only you will have more recursive calls. So L1 and L2 will be the length. So, and then I will find what will be the shortest path from my current cell will be the value of the cell, let's say the grid at I and J, plus minimum of L1 and L2. Because when I'm here, let's say do the origin, the source. And let's say change the value 0 to make it a little better. Let's say this, 3, okay? With this cell, I have L1. I know that from this cell to the destination is L1, and from this cell is L2, L1 and L2, okay? So which one is minimum? Let's say L1 is minimum. So the path, the answer will be 3 plus L1, 3 plus minimum of L1 and L2. And in this way, we can find, the answer. Let's go and write, because we have a little time, I want to go and write a code for this guy. And you will see the nature of the problem is so similar to BFS, but instead of doing in while loop, we have the recursive calls. So let's say we want to define shortest path and we have a grid. We have a grid and let's say source and, let's say I and J. This guy, we are assuming, that in this problem to make this easier, always source is, the 0 and 0, index of 0 and 0, and destination is the most right and, bottom cell, okay? So we want to find the shortest path for this. First of all, we have to check if length of the grid is equal to 0. So we don't have any valids, so we will return none, okay? Or we can return -1. Or let's say okay, -1. And then because in the recursive calls, as you can see, we need to pass, the source and destination also. We need to pass, source and destination. Actually, destination also, again, as I said, destination is fixed, right? Destination is fixed right now. I don't want to make it really complicated. So I will return in the recursive calls, whenever we need to add some variables in the signature of our function, we need to use helper functions. Actually, we define in our recursive inside of the helper functions. We will have grid 0 and 0. This is my source. The source is 0 and 0 initially. And we call this function. And then, let's go and define the helper. You have grid I and J. And I said, destination is the last node, okay? So same as, previous, problem, in the BFS, we need to find, the number of rows and number of columns. And in the recursive problems, first of all, I do the recursive parts. And then I will back to write the base cases. And I will show why I'm doing this. It is really easier to detect what will be the base cases if you write first the recursive parts. So this part is for base cases, right? Let's go and write, the first write, the recursive calls. So what is the potential neighbors? I plus 1 and J, right? So let's say I'm here. Let me write it another color, I and J is here, let's say. The potential neighbors is this and this guy. If you have I and j, the potential neighbor will be I and j plus 1, also I plus 1 and j. Okay, so let's say I want to use the same, approach, same implementation method, we did in the BFS. So I want to write the neighbors. Neighbors are initially is empty, and I will check if I plus 1 is less than rows. It means that, that this one, is inside of the grid. So I want to, actually right now, I'm, checking the validity at first. I don't want to add, extra, potential neighbors. At first, I want to, have only the valid neighbors in the neighbors, matrix. So if I plus 1 is less than rows, it means it is, inside of the grid. Append this. I plus 1 and j is one of the neighbors. Also, we have to check j plus 1 because j plus 1 is the second, the potential neighbor. We have to append here I and j plus 1. So now we have the neighbors. Again, we go and do the for loop over neighbors. Because we have 2, you can, ignore the for loop. But, I want to keep the structure same as, the BFS algorithm we had. So, we need to have, for R and C, row and column in neighbors. So because in neighbors, we have a list of, pairs. And each pair has, R, row and column. And we will call the helper with all the neighbors, right? And every time, let's say, we call this, this neighbor L1, L2. In order to implement the minimum length, we need to have one variable to keep the minimum length, right? So I want to write here shortest length, but the initial value of this should be infinity because we want to keep the minimum value inside of this. So, and you have to import math to be able to use math.inf. So shortest length will be infinity. So I will call helper, let's say I'm calling the helper grid with one of the neighbors. The neighbor is R and C. So the signature is exactly like, the signature of the recursive call, right? So I'm assuming this will return to me shortest length if I go from the neighbor R and C. And I will write, I need to find the minimum of this guy and my current length, shortest length, okay? So I want to find the minimum of the helper, which is one of the neighbors, and my current, shortest length. And I will update the shortest length. So we will go in this, in this for loop, we are calling the helper for all the neighbors, and we are updating the shortest path. After we do all of these guys, at the end, let's say we did all of them, we will return shortest length, okay? So now, one of the things that we have to add is the base case. So in order to find how you should handle the base case, you have to check how you are calling the recursive calls, like here. Actually, we are increasing R at each recursive call or C. Both of them we are increasing, right? So because these are ascending, variables, so we should check upper bound. we should check upper bound for both of these guys because we are increasing them. That's why, as you can see, we have I plus 1 and j plus 1 here. So I need to, what is the upper bound for these guys? It is i's upper bound is rows minus 1. It cannot be more than rows minus. So I will say if I is equal to rows minus 1 and j is equal to columns minus 1. It means that we are in the destination, right? We reach the destination. So what we should do here, so let's say we are in destination. Let's say we are here. What is the shortest path? This is a really basic question. We want to find what is the shortest path from destination to destination. Let's say I and j, we have this, question. This is a really basic question. I and j are exactly the destination, and we want to go to destination. The return value, we have to return the value of this guy, which is 0 here, right? So that's why, we will here write return grid I and j. And that's it, it's done. And now we have, the our, DFS solution. So in DFS solution, always we should see what is the sub problems. And you shouldn't dive into the recursive calls because it is really, it will waste your time and you will be confused, in the interview. And first go and, update, formulate your recursive calls. We did here, the recursive calls. And based on, how you are, increasing or decreasing the variables, the input variables, you will detect what is the, you should check the lower bound or upper bound. And here we detected, so we are increasing the variables. And the grid is, we don't have any change for grid. So we don't need to check the grid, but R and C are changing. So what is the upper bound is row minus 1 and column minus 1. So whenever we are here, so again, we have to think about the meaning of the problem. So let's say we want to find shortest path from destination to destination. What is the answer? So based on the definition of the problem, we'll say, okay, this is because we have weighted cells, we have to return the value of that cell. And we will return here, and it's done.